Hello and welcome to today's webcast brought to you by FDIC. Before we begin, we want to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties during the webcast, please click on the Help widget. It has a question mark icon and addresses the most common technical issues. If you still need assistance, just type your issue into the Q&A widget and a member of our webcast support team will work with you to correct the problem. If you have any questions for the presenter, you can click on the Q&A widget and submit your question. We will pass these on to today's presenter. You can expand the slide area by clicking on the Maximize icon in the upper right-hand corner of the main slide viewing area, or by dragging the bottom right corner to enlarge. In fact, you can expand and reposition many of the components on your screen, so please feel free to arrange as you desire to give you the best webcast viewing experience. For your convenience, this presentation will be available for on-demand viewing within 24 hours of this event. A reminder email message will be sent to all registrants with a link to the archive. It can also be reached from our homepage at fdic.com. Today's event, Using Thermal Imaging and Modern Fire Dynamics to Improve Fireground Operations, is presented by Mike Richardson, Division Chief of Training and Safety, St. Matthews, Kentucky Fire Department. Mike is a 28-year veteran of the military and fire service and is currently the Division Chief of Training and Safety for the St. Matthews Fire Department in Kentucky. He has been an instructor at FDIC for the past 7 years and has taught firefighters in more than 38 states and 8 countries. He has a master's degree in loss prevention and safety, a bachelor's degree in fire safety and engineering from the Eastern Kentucky University. He has a IFSAC certification, Firefighter 2, Driver Operator, Fire Officer 2, Instructor 3, Hazmat Tech, Rescue Tech, and FDSOA certifications in ISO and HSO. He has been an instructor lecturer at numerous fire service conferences.
Start off by saying good afternoon to everyone. So hope everybody's having a good conference so far. I say this sincerely. I appreciate you taking time out of your schedule to come to the class. I know there's a lot of other great classes going on. There's some I wish I was sitting in, and I know the exhibits are going on. So appreciate your time and attention, and I'll do my best to make the best of it and give you the most you can walk out of here with. So real quick, and I'll throw this up, modern fire dynamics. Is this modern? I really honestly am not going to get into that discussion or however you want to say. The reason this class kind of came together was obviously there's a lot of new research, a lot of material that's coming out via NIST, via UL, via some other folks. We've done our best in my department, my agency, which I'm out of Louisville, Kentucky, just down the road, to bring this in and incorporate it. My forte or background obviously is thermal imaging. Did thermal imaging in the military, got in the fire service. Started off my first department using a thermal imaging camera in the 90s and have been working with it ever since. So when I look at something, I kind of look at it and say, well, what's the thermal imaging side of things? Fortunately for me and us, NIST and UL have done a great job when they do their research of incorporating thermal imaging cameras. So thanks to them, one, sharing this information, we have access to it, so hats off to them. And two, thinking about thermal imaging and incorporating it, you're going to see a lot of that. Like I said, there's over 60 videos in this presentation. I'm going to try to do my best to give you that I can of everything as far as different types of thermal imagers. About half of it's my video shot over 15 years, and half of it is either from NIST or UL, or the other one is Kill the Flashover. So also thanks to the folks at Kill the Flashover because they gave me permission to allow me to use some of their videos. So kicking off here, what are we going to try to do? We're going to try to answer the following questions. Are we using thermal imaging to its fullest potential? Do we fully understand the pros and cons? How many people say yes? How many people say no? Okay, good. Probably in this class, that's why. It's out there. It's a tool in the toolbox. How many of you one day showed up and somebody said, here you go? Okay? How many of you actually had a formal training before you were actually putting your thermal imagers in service? That's good, so it is starting to happen. Okay, good. Like I said, the analogy I give is if you take someone that's never had any training in firearms and you walk up and hand them a loaded gun and say, have fun, that's kind of what it could be if you walk up and give somebody a thermal imaging camera without proper training, which some people agree. I think it's a great tool, but it's got its pros, it's got its cons, which is what we're going to try to work on. And are we aware of the new NIST and UL fire? And I say new once again, new's a relative term. I'll be the first one to tell you, some of this stuff, I've been in the fire service going on 30 years. It's not new, but some of it is. But rather than argue over is it new, isn't it new, who invented it, who came up with it, hey, let's look at it. If it's worth using, if it has value, let's latch on to it. If we're already doing it, great, keep doing it. If we're not doing it, do we need to look at it and consider it? And I'm not going to get into the aggressive, safe, all that other stuff where people want to draw lines in the sand. We're all firefighters, all brothers, all sisters. Let's go out, let's do the job effectively, and let's do it safely, and let's call it a good day. So, and can thermal imaging help us do that? So that's kind of where we're at. Once again, new, it either is or it isn't. We'll go from there. Clarify the messages that are out there. Some other folks have said this. I've been here Monday, Tuesday, and Wednesday sitting in classes, and I've heard a lot of messages. Do I agree with all the messages that are out there? No, I'll flat out tell you. And here's the thing. Why do I not agree with some of those messages? I don't think they're clarified well enough. I think we got to watch that we put information out there, but what do we want in this day and age and in this generation? We want a 30-second soundbite, right? Can we explain all this stuff with a 30-second soundbite? Not even close. So the problem is we throw out a 30-second soundbite, somebody grabs it and goes one way with it, somebody grabs it and goes another way, and we're not doing what we need to do. So I think we've got to make sure that when we put messages out there, we clarify them as best we can. This is a message.
Cameras are extremely useful tools for the fire service. As with any tool, while they have a multitude of practical applications, they also have limitations. Operators of these devices must understand ticks are designed to distinguish varying heat signatures in the camera's field of vision. As this example illustrates, they are not capable of reading temperature variations where the camera view is obstructed or thermally shielded from the heat source. Fire service personnel must train with these devices to ensure a level of competence is developed in reading and interpreting tick images, including an understanding that the images provided are not adequate indicators of pending structural collapse.
How many agree with that message? There's definitely good things in there. It has limitations, et cetera. I agree 100% with that. But an instructor on Monday had latched onto this, and his message was what? A thermal imaging camera is absolutely useless when it comes to trying to evaluate structural integrity. How many of you agree with that message? No. But unfortunately, that's the soundbite that got put out there. And to a young, inexperienced firefighter, and they latch onto that, what are they going to do with the thermal imager? Now, I'm not wasting my time. This thing doesn't work, right? So once again, we got to make sure, and hopefully after this class, we are clear on the messages. Can we push fire? Thermal imaging is something that's now allowed us to see things before that we could not see. So I'm not going to tell you yes or no. I'm going to throw a bunch of videos up here, and then you can tell me if we can push fire, okay? Transitional attack. Does it work? Does it not work? Once again, I'm not going to take a side. I'm going to put a lot of videos up here, and I'm going to show you things, and then you can decide, yeah, based on what I'm seeing, this is working, or based on what I'm seeing, this is not working. Because I'm back to the ones that people kind of what gets down to with NIST and UL. I'm here to provide you with information. You take it and do with it as you see fit. Is everybody good with that? So you go back to your department, and you can either decide, yes, we're going to latch onto this and use it, make sure we understand it 100%. We're no sound bites here. We got to get into it. We got to get into it, make sure we thoroughly understand it, and then we'll go from there. Thermal imager effectiveness. Once again, that's why we're here. So if you hear never always, we all know that's false, right? What's the first test-taking strategy they teach everybody? If you see that in the answer, forget it. It's not an option, right? All ticks are the same, or all thermal imaging cameras are the same. They're not. How many would you agree? Now, here's the million-dollar question. How many of you have at least 2 or 3 different types of thermal imagers in your department? That's happening more and more, right? Because we've been around for years. We bought one 10 or 15 years ago, then we bought one 5 or 10 years ago, and then we bought one this year. How many, when you got a new camera, got new training on it? Should everybody's hand go up? Okay, because we've got to make sure we understand what's similar and what's different. A thermal imager is always the answer. There's that word always, so you can throw that one out. No, it's not. It is not the magic silver bullet. It will not save you every time in every incident. So we've got to know when it will help. I also don't know when it's not. And then we have all the answers. I don't pretend to have all the answers. If you see something up here that you feel you need to question me on, challenge me on, have input, feedback on, please do. Because once again, I learn every day. I've been at this 15 years, and I learned something 3 days ago that I didn't know when I came in here on Monday because somebody brought me a video and said, here, look at this and tell me what you think. So please, if you have feedback, throw it in. We need to talk. I will do my best to field questions. This was originally put together and submitted as a 4-hour pre-conference workshop. So I've now got 1 hour and 45 minutes. I've done my best to cut it. I'm going to roll and move pretty fast, but if I'm going too fast, you've got a question to ask. I will do my best to get it in. So is everybody good? So please, if you do. I will stay here till 10 o'clock tonight if you want to stay here and talk about thermal imaging. I know a lot of you have other things waiting on you like cold frosty beverages, but if anybody does want to stick around, I'm here. So we'll go as late as we need to. This is kind of where we're at, like I said, in some situations. You know, people want a black or white answer. They don't want gray answers. You know, people want to either say, hey, we're on the left or on the right. The reality is with this, we're about 60 to 70% in the middle. If you look at the test that I gave you, are some of those questions a definite yes or no answer? They are. Are some of those questions going to have a gray answer? They are. And that's one of the issues we have with thermal imaging is people like it either works or it doesn't. And I'm like, well, it might work here and it might not work here. That's not the answer I want. It either works or it doesn't. So that's one of the issues we're going to deal with here today is, like I said, I'll throw it out there. You can look at it. And then we can get into, hey, is this going to work? Maybe here, but maybe not here, because that's just reality of what it is. A lot of thermal imaging, no pun intended, is gray. But current status of thermal imaging, it's not what we know that's important. What about what we don't? And once again, you've got this test in front of you, so we'll find out what you know. Okay? As we go through the class, I'm going to hit every test question. Hopefully, like I said, you know some of these answers because you're out there using it. But if you don't, make sure that before we roll out of here today, you do know the answer as best you can. So is everybody good on that? So if we hit one of these questions and you're like, hey, I really don't understand this and really don't know that answer, then make sure that we get you that answer because then you can go back. How many of you think if you went back with this test, if you've looked at it, that your people could score 50% on it? How many think 70%? Good, some of that. Anybody think you got 100% at this point? So we do have a couple, okay? I mean, that's the ultimate goal, right? Hopefully that's what we're shooting for. All right. So, improve firefighter safety or not? How many people say it has improved firefighter safety? Has anybody got an example real quick? Nope? Okay. Personally, you know, I've done everything from used it to identify failing floors, pre-flashover conditions, a lot of good stuff. So there's a lot of positive potential there. Is there also a negative potential there? Has anybody had a negative experience with a thermal imaging camera? Okay, anybody want to share or no? Yes, go ahead. One of the things we taught early on was don't let your head get stuck in the box. Situational awareness, right? So yes, we've got to make sure that we don't train and teach people. There's been a battle back and forth. Do we teach recruits how to use it or do we not teach recruits how to use it? Because if you teach them how to use it and then they don't have it, what's the problem? Yeah, they're relying on it. They don't know the old way. So we've always taught them the basics first and then come back with the thermal imager incorporated it. We don't want to take it away from them because they need it and they want it, but at the same time, too, we got to make sure what? We can always go back to the basics. When I started my fire service training, there was nothing I could not do without a thermal imaging camera. Should a thermal imaging camera ever replace anything? It should only what? Add. It should enhance and add. It should be another layer. It shouldn't replace anything. Any other negatives? Depth perception issues, right? Because once again, we're in this box world rather than the real world, right? And depth perception with thermal imaging is definitely one. Safe IR got started because Cairns was selling the Iris. Does everybody remember the Iris, the helmet-mounted camera? Problem was they knew they gave it to firefighters without training what was going to happen. somebody's going to not use it properly and they're going to get hurt. And one of the big issues with depth was depth perception. So they actually got a bunch of firefighters together and said, if you buy one of our thermal imagers, you get training included. Why did that go away? Money, exactly. There's the bottom line. What'd you use to pay for Karen's Iris? 25 grand. What was 5 grand of that? To pay the guys to come in and do the training. Then we started bidding wars, right? Which camera are we going to buy? We're going to buy the cheapest. Who's the cheapest? Oh, we're not going to provide training, and we'll save some money. So that's kind of how we went down that road, but going from there. What do we need to know about thermal imaging? What is the NFPA standard for thermal imagers? Does anybody know? 1801, good. Did anybody use that to buy a thermal imager in the last year or two? Does anybody have an NFPA compliant thermal imager? Yes, no? No? Okay. There are now NFPA compliant thermal imagers out there. So there's about 4 or 5, depending on one model versus one manufacturer. So if you're going to go out here and check out on the showroom or look at the exhibits, there are now NFPA compliant thermal imagers. Do you need an NFPA compliant thermal imager? That's a $1 million question. Everything else you've got is NFPA compliant, right? Or should be. I mean, your pack, your gear, and everything else. So why did we get into this? We got into this because people were going out with a thermal imaging camera and saying, you can throw this off a 3-story building. You can walk through a flashover with it. Could you? You know, there was no testing. There was no standards. There was nothing out there for quite a while. So we had a lot of thermal imagers that were made. They were made to whatever standard somebody wanted to make them to. Fortunately, now that the standard is out, you do have a camera that can withstand falls and heat and bumps and bounces just like the rest of your gear can. So that is an advantage to that. The other issue we ran into was, and that's getting the certification, was using it. If you have an NFPA compliant thermal imager, when you turn it on, it must come up in the basic operational format. That means white hot, black cold. That means no color. That means no bells, no whistles. How did we start thermal imaging? That way, okay? But then what happened? Once again, the sales came in and we got in the issue of, I got a feature, you don't, so guess what? They're going to buy my camera. You know, how many of you have chrome on a fire truck? Fire go out any faster? Right? So, you know, we started adding things to thermal imagers because we could sell something that somebody else didn't have. So they got very, very complicated. And what we said was, we've got cameras in people's hands, and they have no freaking clue how to use it. It is way overcomplicated. You know, it's got color on it. What does color mean? It does this, it does that. So the good news is, NFPA compliant camera, you turn it on, it's going to be in the basic operational format. Everybody should be able to use that. So then there shouldn't be any issues about what point is it going to turn color, or is it full color or partial color. So that was a good indicator of that. You can go into the plus mode or the plus format, and that will let you do all these other things, but you have to do something to get there. Does that make sense? So that's something to check out if you're looking at thermal imaging cameras as far as the standard goes. Now, fortunately, too, we also now have a standard for training because that original NFPA standard did not address training. So does anybody know what the standard is for training? 1408. Good job. Okay. So now, how many of you been through a 1408 thermal imaging training program? Is this a 1408 training program? No, okay? Because if it was, we'd have to what? We'd have to go over all of your policies and procedures. How do you use it? When do you use it? How does it get there, et cetera? Is everybody good on that? What do we need to do for maintenance and et cetera? We'd have to go all over the requirements for who's going to teach you how to use it, okay? And we'd have to also look at what does it need to go over, okay? So look at this standard because if you have a training program, should it meet the standard? Yes, okay? The other issue we're running into with this, though, is usually when we have an NFPA standard, what do we have to go along with it to help instructors? JPRs? How about a book or a manual? What are we teaching from? Does everybody see where I'm getting at? Do we have that book? No. So we've still got the final hurdle we're going to have to get over is coming out with a book or a manual that gives you the information you need to meet the standard. Because right now, where do you have to get this information from? Wherever you can get it, right? So wherever we can find it. Question, comment, sir?
Yeah, if you have a thermal imaging on your equipment, should you also have the other things you're talking about, such as training and guide, SOPs, things like that?
Yeah, the question is, I mean, should you just once again show up and throw somebody a camera and say, there's the on and off button in white hot and black cold? No, right? I mean, we should have policies and procedures, like I said. How and when do we use these? How and when, what do we need to do for maintenance? How many of you have a policy and procedure for maintenance on your thermal imager? You got a policy for maintenance on your other equipment? So should we have that? Make sense? Yes, sir.
Mike, in your experience, was that thrown on great no training? Is it a litigation issue down the road? Have you ever heard anything?
Oh, and I'll do this as best I can without stepping on any toes or getting into it. Have there been firefighters who have died in the line of duty due to an issue with a thermal imaging camera? Yes. If you go back and read the NIOSH line of duty death reports, you can find them. Has litigation resulted out of that? Yes. Now, has it been directly to that one issue? No, it's been a big issue, but has somebody come back and said, you put somebody in a situation that they were not adequately prepared for, as a result, death came about, you are therefore liable, yes? Yes. I mean, that has happened, that has gone on. So food for thought, and once again, if you're looking for ammo to try to get your chiefs or administration to step up to the plate, I mean, it's a huge issue because it goes back to, do you wear NFPA compliant bunker gear? Sure. Have you had training on your gear, your SCBA? Sure. So now why do we hand you a thermal imager and deviate from that? We shouldn't, right? Everybody agree? So, okay. So basics of thermal imaging. This is kind of running through this, and we need to understand all this. Hopefully, if you're using a thermal imager, this shouldn't be news to anybody. But as we run through these test questions, if you don't know the answer, then we probably have got issues. Would everybody agree? So, running through these. We start off with the thermal imager, front end to back end, lens, detector, processing, and we've got a display. That center part is the detector. That is one of the main things that's changed in the last 10 or 15 years. A lot of the stuff hasn't changed, but we need to make sure we understand what type of detector do we have in our thermal imager, because that will determine what it does, how it does it, and et cetera. And if you've got 3 different thermal imagers, what might you have? 3 different detector technologies. So is everybody good? So that's something we need to make sure we identify and we look at. So what detector technology is in your thermal imager? Show of hands, how many of you honestly know what type of detector you have? What do you have? So you've got a microbolometer. VOX is vanadium oxide, which is the detector, and ASI is amorphous silicon, which is the other detector technology. You need to know what kind of detector you have because, as you see, it's going to determine how it performs and what it does. The ferroelectric BST, that was the very early cameras that came out. Since then, we've all pretty much gone to microbolometer cameras. How do you know what type of detector technology you have? Check your user's manual, exactly. Pull out your bid specs, pull out your user manual, check that. How many of you have a camera and have read the user manual? Okay, and I love that too, because here's the camera. Where's the user? We don't know. We got a camera, right? Exactly. Can you find most of that stuff online? Yes. So once again, get out there, dig it out, homework, look it up, right? The answer to this is up to you. I mean, there is no set answer for this. It's based on what you actually have. Like I said, the ferroelectric BST cameras, they were the first ones that came out. So if you bought a camera 10 years ago, 15 years ago, one of the larger format cameras, that is a BST type thermal imaging camera. Those are no longer in production. Guess how we got our thermal imaging cameras? Anybody know the story? Most say military. Okay, you ready for this one? Cadillac was going to add a feature to the Cadillac where there was a thermal imager mounted in the grill and it gave you a heads-up display. So as you're driving down the road, you can see through fog, see at night, etc. Okay? Was that an expensive option on a Cadillac? You bet. So expensive car got even more expensive. Well, guess what? They didn't sell them. So they had this huge pile of BST detectors laying around. So somebody said, we need to sell these. So guess who was looking for thermal imaging cameras? The fire service. Guess where your first thermal imaging cameras came from? Courtesy of a Cadillac not selling them. Okay? Believe it or not, that's the truth. Now, the microbolometer technology is what? That's more the military technology. That's more the newer stuff, more the updated stuff. So that's kind of how we got into it. So if you see one of these up here, you have a BST camera. If you don't see it up here, it is a microbolometer-based camera. So is everybody good on that? So do you know now which one you do or don't have? Okay? All right? Pros and cons, they've got them. If any salesperson tells you otherwise, that's their job, don't listen to them, okay? My job at Bullard was training, but I always got sent out with a salesperson. What did I have to do half the time? I'm not going to say anything. I'm not going to say anything, right? Okay? You know, they're going to tell you the pros. They're not going to tell you what? The cons. Everything has pros and cons. And like I said, anybody tells you otherwise, they don't have the story. So when you get back, one of the keys is for you to figure out what are the pros, what are the cons of your thermal imager. Obviously, use the pros and avoid the cons, right? Okay, so that's what we're going to try to do. What is the size of the focal plane array in your thermal imager's detector? Your detector is a little sensor. It's made up of pixels. So how many pixels? Where do we relate pixels to? When you buy a TV, what do you want? 1080, right? HD, you want all the pixels you can get, right? So normally we relate pixel count to things like image quality on a camera or on a TV. The more pixels you have, the better the image quality can ultimately be. So is everybody good on that? So more pixels equals better image quality. So we good on that, all right? So what size do you have? If you had a BST camera, it was a 320 by 240. They all were, okay? That is, if you do the math, that's 76,000 pixels. Versus if you bought one of the new very small format cameras, that may have an 80 by 60 detector in it. That's only 4,800 pixels. Are you going to see a significant difference in image quality potentially? Sure, okay? You know, this may mean the difference between using this and being able to go, hey, there's a big white blob in the corner, versus using this and being able to say, hey, that big white blob is what? A person versus a fire. Does everybody see what we're talking about here? So when you buy your thermal imaging camera, this is something to consider and look at. They've also now come out with a 384 and a 240. So you may even find these down on the floor right now. Higher pixel counts equals better image quality. So is everybody good on that? Now, you've got what you've got. If you ended up with one of these 80 by 60s, is it useless? No, it just means it won't necessarily give you the image quality in some situations. Is everybody good on that? So learn how to use what you have as effectively as you can. Bottom line, right? We got it. We got to do that. But if you're looking at future purchases down the road, more pixels is always better as far as image quality, okay? So looking at the differences, this is BST, the original. These are 2 microbolometers. Once again, Vox is vanadium oxide, and the other one is ASI amorphous silicon. You will find both of these being sold today. Once again, you may have one of these, but they're not being sold. Is that the same image quality? Does that look the same to you? So if you were trained to use this, and then all of a sudden now you're staring at this, do you know what this means? Because here was my favorite thing. I'm crawling in behind a firefighter, and he's got a thermal imaging camera, and the next thing I know, he is flat knocking me over going backwards. That means what? Time to go, right? If he's going, I'm going, right? So we go rolling back out, and we end up on the porch, and I'm like, man, what happened? And he went, red. And I went, red? He said, camera, red. And I said, okay. He said, red is bad. Red means flashover. I said, no, red just means it's probably above 400 degrees. It's a fire, okay? So had that person been properly trained? No. Did they have any clue what red meant? Nada. Somebody in their head, for whatever reason, because either somebody told them or they thought, what? Red means run away. Red doesn't necessarily mean run away. Could it? Yes. There's some cameras, I got news for you. If you're seeing red, you better be running. You better be running hard and fast, okay? But we've got to understand when we look at this stuff, what does it mean, okay? We've got to translate it. Once again, fire condition in a wall, are they all showing it the same? Microbolometers are relatively close, but the BST doesn't quite look the same, right? So once again, when I see this, is this a hot water heater on the other side of the wall or a hot air duct, or is this a fire condition? It just does what? Here's the image. I've got to what? Figure out what I'm looking at. Once again, if I was used to seeing this and now I'm seeing this, can I make that transition? So as we change models, change detectors, we've got to know what's similar and what's different. Is everybody good? Vent conditions, showing a lot more heat here than here or here. But it's the same condition, but it's 3 different cameras going to show it 3 different ways. Now, this once again, we start off with the fire. Now the $1 million question, where's the fire? It's to the right. Can everybody see that? So initially I can pretty much say all cameras are showing me. But now with this camera, is it clear what direction that fire is coming from? Not near as clear as that one. Does everybody see the difference? So I could tell you, hey, there's heat down the hallway here, but I may not be able to tell you what direction that heat's coming from. Here I can clearly tell you the heat's coming from the right, so the fire's got to be to the right. But also, if you'll notice, there's the number 1, the number 2, the number 3. Can you see that here? Can you even tell what's at the end of this? Does that make a difference? Sure. I mean, it goes back to what type of camera you have. What is the image quality? Anybody want to guess what detector size this is? That's one of those very small detectors, right? So yes, it's showing you heat, but it can't show you the detail these can because it doesn't have that image quality, that capability. So is everybody good while we're looking at this kind of stuff? So we've got to know, because right now I can't tell you what's at the end of this other than smoke. That's why we use thermal imagers, right? But with this camera, I can tell you the thermal condition's about 50%. I can tell you it was coming from the right, and I can tell you it's about to get ugly in here. Would you agree? Can you tell me any of that with this? All I can tell you is, hey, it's hot up there, right? So does everybody see the difference? So make sure when you have your cameras, practice them, use them, you know, because I hate to say it, where do most thermal imaging cameras get sold, or a lot of them do? Fire station, guy shows up, check out this camera, check it out. You know, and you look at it, and there you go, hey, this looks great. But then you get to the burn building or that first fire, and you go, what? This don't look so great anymore, right? So make sure you have a realistic expectation for what your thermal imager is actually going to show you and how it's going to show it to you, because they are not all created equal. Would everybody agree? So once again, future purchases is something to think about. So is everybody good on the differences in technology? So when you go back, do you need to do your homework and figure out which one you have? And then do you need to make sure if you have different models that you're explaining to your people, hey, this is a BST camera. It works this way. Hey, this is a microbolometer camera. It works this way. Put them side by side. Look at them. Compare them. Is everybody good? Agree? Is that important? Very. Question, comment?
BST is the older technology. Why does it look better up there?
Don't ask. Don't ask. Don't ask. All right. Here's the key, and I'll tell you this. BST in some situations looks absolutely phenomenal. However, has anybody heard of the term whiteout? What would happen, and where that term came from, was the original cameras. They would get to a point where there's so much thermal energy, they would go white. Now, BST was not full whiteout because the original camera I had was even a generation before this, photoelectric Vidicon tube. When the guy came and trained us, he said, do not look at the fire with this camera. And we're like, what the hell are we supposed to do with it? He said, if you look at the fire, it's going to go white, the tube's going to burn out, and it's done. So it was like fire, oh, don't look at it. Fire, oh, don't look at it, right? Okay, BST, if we look at it, it would go solid white, so we would lose our image. The good news was if you looked away, it would reset and it would come back. So that was why they kind of wanted to go away from BST, because it would do that. Microbolometers constantly adjust their sensitivity. So when they were getting to that point where they were going to go solid white, what would they do? They would back their sensitivity down so that didn't happen. So is everybody good? So you're going to see a lot of videos of both through this presentation. And there's times, I'm going to be honest, yes, BST looks phenomenal, and I would rather have it. I still have a BST camera at my department. Guess who uses it? Me. It's in my buggy, and it stays with me, and I use it, okay? Most of the other guys, it was when the big red bullard said what? I don't want to carry that big heavy thing around, you know. Give me that little one. But now when we look at image quality, guess what? Can we borrow your camera? You know. So does that make sense? Answer your question? Okay.
I remember the heat sinks, too, that some of the old cameras.
Yes. Yeah. I mean, the old cameras, the Viper, you had to switch out heat sinks because, once again, it was a thermal issue with loading up on energy. So, yes. I mean, that's kind of how we've progressed through the years, if you will. How many operating modes does your thermal imager have? Don't confuse this with the NFPA compliant cameras. An NFPA will have basic and plus. So is everybody good on that? That's an NFPA compliant issue. I'm asking now operating modes. And this will only be on microbolometer cameras. BST cameras only have one operation mode. Microbolometers could have multiple modes. Do you know how many modes your camera has? So you have a 2-mode camera and a 3-mode camera. Is everybody good? So the answer, what is the answer? What do you have? Okay? Because there are 2-mode cameras out there and there are 3-mode cameras out there. But you need to know which one you have. Why? Here's why. This is in the high sensitivity mode. That is in the low sensitivity mode. Everybody catch what just happened? So it starts to see a lot of heat of energy, and it's going to saturate. So what does it do? It dumps its sensitivity. So is everybody good on that? Uh-oh, that's not good. Sorry here, we may have to start over, but we'll see. Keep our fingers crossed. Oh, yep, sorry, I don't know why that was, but we'll jump back in here. All right, let's try this again. Keep your fingers crossed. Okay. So, is everybody good on those two modes? All right. Now we're going to take a look at a 3-mode camera. High sensitivity, medium sensitivity, and it says EI, which is electronic iris, but that would be low sensitivity. So does everybody understand what's going on? The camera is changing its sensitivity or its gain based on how much energy it sees. So you could have 2 changes or you could have 3 changes. So is everybody good on the modes? Once again, you need to go back and figure out, do I have a 2-mode camera or a 3-mode camera? So everybody says, well, why? What difference does that make? This is high sensitivity. This is medium sensitivity. This is low sensitivity. So does everybody understand what's going on? As the camera sees more and more heat, what does it do? It keeps dumping its sensitivity so the screen doesn't go solid one color. But you're going to see some issues here with that, all right? So here's the 3 different modes. Low sensitivity, how's that looking? Not great, right? Medium sensitivity, how's that looking? For that scenario, that's probably where I want that camera because that gives me the actual best image qualities. Everybody see that? Now that is high sensitivity. All right, and this is why this is important. Did anybody catch anything in there that you should have caught? Say it. Does anybody see the downed firefighter? Right there. Helmet, arm, legs. Does everybody see him now? Can you see him in that? Can you see him in that? Does it matter what mode your camera's in? Depending on what you're trying to do, so does everybody understand? Because now here's the $1 million question. How do you get your camera into this mode? Can you manually control it, or is it based on what? How you use it. Does everybody see where I'm getting at? Because everybody wants to point the camera at what? The fire. What mode is that going to put it in? Low sensitivity. What did that just do to your image quality? It tried to clear it up for the sake of showing you the heat source. But do I really care about that? At that point, what do I want to see now? I want to see that downed firefighter, or I want to see doors or windows or details. Does that make sense? So how do I get it into this mode? Don't go to the fire. Does everybody see? So what I'm going to do is that rather than going to the heat, I'm going to keep it away from the heat to keep it in one of these 2 modes. Does everybody see how I'm doing that? That comes down to operator capability, understanding how to use it, understanding how to make it do that. There are some thermal imagers that will allow you to control the mode, but that would have to be a plus feature on the camera. So is everybody good? Most manufacturers will not let you control the mode because they're scared that you will do what? Put it in this mode when you should have it in this mode. Does everybody see what's going on? That's why the majority of cameras, this is automated because they said, we're just going to automate it because we don't want an operator screwing it up. But as an operator, do you need to know how to actually use your thermal imaging camera? Whether that's manual or whether that's how and where you're pointing it. So is everybody good on modes? Did anybody learn something that you didn't know prior to coming to this class? So does everybody understand? This is what we got to get into. This is what we got to understand. Because if we don't, we're not using our cameras properly. Would everybody agree? Because like I said, if 90% of firefighters, where's the camera going to get pointed? Fire or heat. What's that going to do to your camera? It's going to dump the sensitivities. Everybody good? What do we usually want? Sensitivity, because I'm either looking for victims, looking for a downed firefighter, looking for navigation. Now, if I'm trying to monitor heat, yeah, at some point I'll go up there and look at it. But I don't want to hang out up there, right? Because if I do, I'm putting myself in this situation. So is everybody good on that? Question, comment?
How long would it take for it to clear the screen once I get into that high sensitivity mode to drop it down to medium or low?
Most of them are a couple seconds. Now, some of them will have a lockout because what other operators also like to do? What's the camera trying to do? It's freaking out, right? Because it's going high, low, whoa, high, low, whoa, whoa. So some of them, if you're doing that, it will lock out for a certain period of time until you stop, and then it will settle in. Does that make sense? But most of these will shift within a couple seconds. But you need to practice with your camera and see, where can you do this? What if you don't have a burn building? What do you need? A heat source. Turn on your stove or gas at your grill or your oven at your firehouse and practice with your mode shifts. Then you can see how it shifts and when it shifts and what it does. So is everybody good? I just need a strong enough heat source to cause it to shift. And you can do that with a gas burner or gas grill. Is everybody good? Burn building is nice because that's realistic. But if you don't have it, can you do this at the firehouse? Sure. Question, comment?
Yeah, the NFPA approved now thermal cameras out there. What are
They will shift modes automatically. So the new ones will shift modes because they will not let you manually do it because they're going to default to what? The KISS mode. The KISS mode is automatic. But if I'm not using it properly, is it a good thing? No. Does everybody see where we're at? So, and it's a catch-22 because someone said, well, why don't you just lock it out into high sensitivity? Because if you point it at the fire, what's going to happen? Your whole screen's going to go white or red. That's not going to help you. Does everybody see? Whereas here in this medium sensitivity, I've still got some resolution here I could use. So does everybody understand? So that's kind of how we got to this point. Can't see it, you can't deal with it, right? So, all right. What color display options does your thermal imager have? Is there a single answer? No, right? So there is no consistency. We can have full color, we can have partial color, we can have color at a certain temperature, all kinds of stuff, right? So the key is, what is the significance? What did that firefighter think red meant? To run, right? Is that the same? No, it may or may not be. So you've got to go back and do your homework. What does color mean? At what point is it going to add color? Once again, if you've got an NFPA compliant camera in the basic mode, it will what? Not show color. It will strictly be black and white. If you want color, you have to kick into that plus mode. Is everybody good? Because once again, what's it's easy to train people on? White's hot, black's cold. Versus I've got to train you, the first time it turns red is what? This. The next time it turns red is this. And then somebody starts going, when the hell does this thing turn red? So is everybody good? So looking at some examples. What temperature point? Could it be 300? Sure. Could it be 1,000? Sure. Depends on your thermal imager. Got to go back and do your homework. Pull out your owner's manual and look at this. This is 2 modes. Well, with 2 modes, guess what? 2 different color points. Here, red is at 300 degrees. But when it shifts in the low sensitivity, it won't turn red until it's almost 1,000 degrees. Now, where does this cause a problem? Oh, it's red. And I look away, and it shifts modes. Did I catch that? I didn't. And now I look back, and it's not red anymore. What do I think? It cooled off. Did it cool off? It may have actually gotten what? Hotter, because that's what caused it to shift modes. Does everybody see what's going on with this? So you've got to make sure that when you have a camera that has different modes and different color points, that you're aware of that. Because if not, someone's going to take a camera and see color, and then all of a sudden, color's gone. And they think, what? It just got cooler. It didn't. It actually got hotter. It's caused it to shift modes, and now it's coloring at a different point. Does everybody see how that's working? So you've got to make sure that you're aware of that. This is another 2. Whoa, there's a lot of color. There's a lot of heat. Oh, well, the heat just went away. No, the heat didn't go away. We what? We changed modes, so we changed our color points. Usually on your cameras, your scale will change. Does everybody see how that's happening? So once again, what was my initial color point? 500 degrees. Okay, we got 500. Did it get cooler? No. Now it's going to turn colors at 12. But hey, I've still got some red in there. So does everybody see how that's working? So you've got to go back and pull out your camera and figure this out, because there is absolutely no consistency through the industry. Is everybody good? That's one of those things that we're still dealing with. So it's happened. It's the way it is. Now we look at a 3-mode camera. We can have the same thing. High sensitivity, I'm red at 200. Medium, I'm red at 450. Low sensitivity, I'm not red till I'm 2000. So does everybody see how that's working? So you've got to understand your symbology. What does this mean, and what does this temperature scale mean? Is everybody good? That way, hopefully, I can understand what's going on. Because if not, you're going to have people seeing colors come and go and not really understand what's going on. Because they're not understanding, is it really getting hotter or is it really getting cooler? So we've got to make sure that we figure that out. This one is in high sensitivity. Boom, it just shifted to medium. And then you would see a final shift here again. So is everybody good on modes? Yes? Is everybody good on color? Do you have homework to do when you get back home probably? Is this very important to train your people on? Because without this, do they really understand what is going on in front of them on the thermal imager? So are we good? Okay. Is the thermal imager equipped with reverse polarity? This was on some cameras early on, and then they started to take it off. Now they put it back on. The good news is, an NFPA compliant camera in the basic mode, this is not an option. And here's why. What is reverse polarity? This is white hot. This is what we use, yes? Well, if you have reverse polarity, guess what? You can make black hot. So here's what was happening. You got the techno geek, right? Everybody does. So give me that camera, man. I'm going to play with that thing, right? So he plays around with it and decides what? Yeah, I like black hot because that looks better, and now he throws it back on the rig. Do you know that? So now you grab it and look up and go, oh, it's dark in here. We're good. We're cool. It's what? The opposite. Does everybody see? If you have reverse polarity on your camera, you better make sure that you know it's there and better make sure your people understand what's going on. Because if not, somebody's going to be screwing around with it and flip it, and it's going to get put back in service, and now somebody's going to pick it up and go to use it. Do you see a big issue here? So once again, if you've got an NFPA compliant, it can't do this in the base mode or the basic. It can in the plus mode. So once again, if you've got that person that likes playing around with the camera, you've got to be aware of that. The good news is, with an NFPA compliant camera, once it's turned off, every time it's turned on, it comes back in that basic mode. So that's your saving grace. So if you've got a camera that's NFPA compliant and is doing something you don't like, what? Turn it off and turn it back on. It'll come back in basic. Because that way, if someone else was using it and changed something that you don't like or don't understand, shut it off and turn it back on. It'll come back in white hot. Is everybody good on that? Question? Yes, sir. Thermal throttle adjusts the sensitivity. That was an attempt on the BST camera to kind of compensate like a microbolometer does. There was a feature on the BST cameras called the thermal throttle. It was a little knob you could adjust, and it changed how much energy could come in or out. Why did we put that on there? To try to combat that whiteout issue. That way you could dial the sensitivity down and it not white out on you. But could that change what you're seeing? Yes. So is everybody good on that? It's another feature there. Temperature measurement. How accurate is it? Nothing? That's
nothing, but not what you're looking at.
Exactly, and here's the key. Was this a big selling feature on cameras? The original cameras did not have it. BST could not do temperature measurement. If you wanted to do temperature measurement, you had to add a separate component. Microbolometers can do temperature measurement straight from the detector. So that's a difference in technology. Question or comment, sir? I don't want to get too far. Yes, there should be. So there should be some type of symbology to show you that it's reversed. Is it consistent? No. So is everybody good? So once again, you've got to know your thermal imager. Question?
I thought with the thermal throttles, they're offering that again like Roller is offering that.
It's different because it's now on a microbolometer, not on a BST. And what that feature does is it allows you to tell it to start adding color at a certain point. So if you've got like a T3 or T4 with what they call a thermal throttle, that allows you to adjust the point at which it starts adding color. So that's a different type of feature on a microbolometer versus the thermal throttle on the BST. So is everybody good? Difference in temperature, difference in features. Does that make sense? Get your question? Okay. So temperature measurement. These are all the things that affect temperature measurement. I had to go through an 80-hour course to be certified to measure temperatures with a thermal imaging camera. Who does that? Power companies, because I got to decide if we're going to replace that transformer on a pole from 100 feet down, because I don't want to have to climb up there. preventative maintenance people. Am I going to change the bearings in this motor now or 3 days from now? So there are people that need very, very accurate temperature measurement. But to get that, you've got to take all this stuff into an account. And it's 80 hours worth of training for level 1. Okay? How much training have you had on temperature measurement? Can you even address all these issues? Do you even know what all these issues are, right? So now let's break it down into the fire service. What do we really need to focus on when it comes to temperature measurement? What I want to focus on is the surface, the reflected energy, and the distance. Those are the 3 things we're going to focus on, because for most firefighters, that's what matters, okay? And this gets back to how we're going to use it. So is everybody good on that? So, surface. The key to remember with the thermal imaging camera, it can only accurately read a surface temperature. It can't read the temperature of gases or air. Does anybody see an issue with this? Okay, here we go. So, we've got our propane torque. How hot? Hot, right? Somebody's like, hot, 600, 800 degrees, it's hot. Well, that's interesting because according to our temperature measurement feature on our camera, it's a whopping 114 degrees. Does anybody see a problem with this? Because when you crawl in there and that flame front is rolling over your head and you throw the temperature measurement feature on the ceiling, are you necessarily going to get an accurate reading? No, because it can't tell that flame is really there. Now, will it to a certain extent? Yes, because some of that energy will be what? Reflected off of the surface behind it. But will it necessarily give you an accurate reading? No. Okay? That was one of the issues we got into early on when they started adding temperature measurement. I'd hear the salespeople go in there and point it at the ceiling. If it reads anything above 500 degrees, you need to go. That was complete, total, utter what? Garbage. Okay? So we were mistraining people how to use it. Does anybody still hear that going on? I still do from time to time. So be careful. Temperature measurement is not our end-all to be-all, right? It's a tool, we can use it, but you're going to see there's a lot of issues with it. The next one, like I said, is that reflected energy. So once again, when somebody says, well, I've crawled in before and pointed it at the ceiling and it went to 600 or 800 degrees. It's registering some of it, but it's not necessarily registering all of it. Does everybody see where I'm getting at? There's a prime example here. Once again, you can do this in the firehouse. How hot is that flame on the stove? Pretty hot, right? So let's check with our camera again. Well, according to this, it ain't broke 300 degrees yet. And that's both at the flame and what? The reflection of the flame off the back. Does everybody see how that's working? It's registering some of that energy, but is it registering all of it? Not even close, because we know a gas flame's a hell of a lot hotter than 300 degrees, right? So this gets back to, there's a lot of issues with temperature measurement. You've got to be very careful and relying on it in firefighting for very accurate numbers, because there's a huge room for error here, okay? Another example we've got is called distance to spot. Thermal imager temperature measurement is not a laser beam. It does not go out and hit one point. It's more like a flashlight. It's a cone. So the closer I get to the object, the smaller the area it's measuring. But the farther I get, the larger the area. Does that make sense? Does everybody understand what's going on? The issue here is I want the temperature of object Y. So I put my crosshair or my X right here. But what is it also factoring in? All the background. So if this was 300 and this was 100, is it going to tell me it's 300? No, it's going to tell me an average, right? So once again, in your firehouse, if you want to prove this out, you put a hot object on the wall and stand back from it. That hot object is just an iron like you iron your clothes with, okay? So at this distance, we're getting readings off of it in the 70s and 80s. Why? Because it's averaging this wall temperature in with this. Because the camera right now is actually probably measuring the temperature of an area about that big. Does everybody see what's going on? So now as I start moving closer, what's happening? Temperature's going up because that cone's getting what? Smaller and smaller, and I'm averaging less and less. If we look at this, we started off at 30 feet at 71. At 5 feet, we were reading 325. Anybody see a little bit of a difference there? So once again, you've got to be careful on how we're using this, because I see this all the time on smells and bells calls. Somebody comes in and shoots something that's up high because we don't want to what? Get a ladder and go check it. And somebody says, it's 80 degrees. Don't worry about it. Should you worry about it? Can everybody see what's going on? So make sure that you're covering these things with your personnel. Make sure they understand, hey, this is not rock solid when it comes to gases. Hey, this is an issue, can be with reflected energy. Hey, watch that distance to spot issue. So is everybody good on this? Does this make sense more now in temperature measurement? Can everybody kind of see some of the issues? Okay. How accurate is it? My answer is going to be none of the above, right? Now, could it be accurate in certain situations? Yes. Do you need to do a lot of homework and really understand your camera in order to say it's accurate? Yes. So is everybody good on that? Okay. Accuracy varies greatly. What forms of heat and energy transfer can we see? Conduction, convection, or radiation? $1 million question, right? All of them. Now, could that be imager specific? Yes. Okay. Once again, what did that BST camera do a bang-up job of showing me? Convection. Is everybody good on that? Did everybody see that convected heat energy? Did those microbolometers always do a bang-up job showing convection? Not necessarily. So is this somewhat camera specific? It can be. They should show you all three, but once again, we've got to look at it. So let's look at our conduction. I may have to do something like this. Conduction, right? We're moving heat or energy through a solid surface, right? So somebody tell me where the fire's at in this scenario. Is it in this room? Is it in an adjacent room? Okay. Look at the floor. It's white. Where's the most heat? Below us. Why do I have this weird pattern in the wall? Though that is a metal frame building. Is metal a good conductor of heat? That's why we're seeing that. Would you see that if that was a wood frame building? No. Does everybody see what's going on? So we got to understand how our building construction translates to what we're seeing when we talk about things like conduction, right? Do I have good conductors or good insulators? Wood obviously is a good insulator, but metal's a great conductor. So we've got to understand we're using our thermal imager. What are we seeing and why are we seeing it? How does that relate to building construction? Can you identify a pipe chasing a wall? If it's good conduction, you probably can, right? So if we've got fire traveling different ways, that's a good question. But if the materials are good insulators, can we see through anything? No. Thermal imagers, right, aren't magic. They don't see through things. But we can see what? Heat and energy that's transferred via conduction. So is everybody good on that? All right. Convection. This is clean, hot air. This is a hot air gun blowing it on a piece of wood. Can you see it here? No. Camera can't see clean air. But when it hits the surface, or when it's what? Smoke is what? Dirty, right? Smoke actually has particles. So what I'm actually seeing is the particles, which is a good, if you remember, smoke is fuel. Does everybody see? I'm seeing the fuel here. So is everybody good? So once again, do all cameras show it the same? That's a beautiful thermal layer. If you can't freaking see that on a camera, you're blind, which some people are, right? Don't forget about that. That's an honest issue. I handed a camera to a guy one time, and he's like, I don't have my glasses. Here, you can have it back. Is that an issue? Can be. I mean, if your guys don't have glasses inserts in their face pieces, they may not be able to see what's on the screen. But that's a really good thermal layer. That is a BST camera. Does a bang-up job of showing it. If that's a microbolometer, is it going to look the same way? You may just see what? A big white area across the ceiling. So is everybody good on that? This can be camera model technology specific. Now, is everybody familiar with Dave Dotson? I stole this from him. Can you read the volume, velocity, density, and color of convection? Yes. I mean, you can read that with a thermal imager just like you could read smoke with the naked eye. So remember what Dave has taught you about smoke, you can also use that to read convected energy. Because obviously, if the volume is up, we've got what? A lot of heat. If the velocity is moving, what's moving it? The heat, the energy, right? If you see this stuff getting denser and denser, what is happening? More and more fuel is being pushed into it. Is everybody good on that? And then obviously the color, once again, whiter is hotter, or red, or whatever you're using. So you can also use that here. So think about that. And then finally, radiation. Is there a fire in the basement here? Could be. right? So when in doubt, check it out. But what I'm actually seeing here, all this heat is getting what? Radiated down into the floor. What does this lead to? Flashover, right? What happens is that's saturated. It can't hold any more heat, so what does it do? Radiates it down. What does that do? Breaks down all of our combustibles and starts adding to that thermal layer, correct? So is everybody good on that? So what I'm seeing here is not a basement fire. I'm seeing all this heat energy being radiated. Can you see it in the air? No, but you can see what? Where it strikes and collects on a surface. So is everybody good on that? So once again, do your people understand what they're seeing and why they're seeing it? Okay? Which materials will long-range infrared not pass through? All the above. Okay, good. Glass. Will it pass through glass? For every rule, there is a exception. That is an old lead glass window that you will find in a 1800s, early 1900s farmhouse. Infrared energy will pass right through the glass. If you've got those windows in your house, guess where your heat goes? Right through the window, literally, okay? So remember, for every rule, there's an exception. Normally, we can't what? We can't see through glass. We can't see through polycarbonate. There is one exception. There it is. When we look at things like plastics, we had a grocery store. We had a fire in the back of one of the freezer units. Our guys went in and we kept telling them, Charlie Delta Corner, Charlie Delta Corner. And they kept calling out, we're there. There's nothing here. Where were they? They had one of these plastic walls created to keep the refrigerated stuff behind. What did it look like to them on the thermal imager? A wall. I mean, they couldn't differentiate between the wall and the plastic. So is everybody good? So once again, things you got to think about and be aware of when you're trying to use your thermal imager. Water, the old magic trick. Now you see it. Now you don't. So remember, it can't pass through water. Where else can this become an issue? Sprinklers. I've had people call out and say, we're as far as we can go and I can't see anything. What are they actually seeing that they think is a wall? Water spray coming down that looks like it's solid. If you get 2 or 3 heads going off, a lot of times you can't see through them or past them. So if you're not careful, somebody does a quick check, it appears to be a solid object to them. It's not. So is everybody good and see where that can cause issues? All right, and steam, obviously we can see through, or the camera can, but what's the feature that's missing off a thermal imaging camera? We've always said. Windshield wiper, because what happens to it in your face piece? Condensation, right? You're always having to wipe, you know. What can you see on the camera? Nothing. Wipe your face piece. Oh, yeah, okay, I'm good now, right? So something to think about. What color shade will a victim be in a fire? Good. All the above. Yep, right? White, gray, dark. It's always relative to what? The background, the environment that we're in. And if you want to see the real magic trick, here you go. White, gray, black. Did the temperature of their hand change? No. What changed? The background changed, which caused that to change. Does everybody see where this can be an issue? Okay? So once again, we've got to understand what we're actually looking at and why we're seeing it. Okay? Because I've heard people go in saying, hey, it's a victim. You know, hey, look for this, or hey, look for that. Contrast. Not good contrast, right? Things are kind of blending together. Good contrast. Hey, I can see product levels in those drums. Why can I see it here and not see it here? This has been sitting in a climate-controlled warehouse. What is the temperature of everything in here? It's all the same. Camera can't see a difference. This is a non-climate-controlled warehouse where things can what? Heat and cool. Liquids will what? Cool faster than a solid. So does everybody see what's going on here? This could have something to do with the camera quality, but more times than not, it has to do with what? The environment. What's going on in our environment. So is everybody good on that? Everybody can see what happened? Because I've had guys go in with a fire on the second floor, and they're tripping and falling over furniture on the first floor. Why? Are the chairs the same temperature in here as everything else is? Pretty much. Does everybody see where that can cause an issue? But as we get closer to the fire, our temperature is going to change more quickly and more drastically. So what's one of the ways I know I'm getting closer to the fire? My contrast usually gets better until everything starts getting what? the same temperature hot, and then all of a sudden I go back to low contrast. Does everybody understand the difference? But one is going to be low contrast hot, and one's going to be low contrast cool. Does everybody kind of see the difference in what's going on there? All right. Now, can we change contrast with water? Yes. If we're looking for a down firefighter, try to avoid putting water where? On the firefighter. Because if I rake the bottom of this room with water, what did the temperature all just become? The same. Does everybody see what can happen? And now I'm trying to use a camera and it's not working because it can't show me a temperature difference where one doesn't exist. But if I hit everything up high and can keep it up there, will that help with the bottom? It could. Does everybody see the difference? So that's something to think about, all right? We also try to tell our guys before you dump water in a room, if you can, what? Quick peek it with the camera and then dump water in there. Because once water goes in there, what happens to contrast? It's gone because it can wash it all out. So does everybody see a difference? Okay? All right. What are you seeing? What does it mean? Where's this handprint coming from? Am I going to put my hand on this or am I going to do what? It's coming through. Does everybody see what's happening here? That is what? Conducted energy. Can I see that victim with a thermal imager on the other side of the door? No. When I go to the thermal image, I can't see them, right? But what can I see? I can see my reflection. Did some of you catch that? But when they're in contact, what's happening? Energy's being transferred through. Does everybody see what's going on there? So can everybody see what can happen here? Remember, camera can't see through that glass, but it can do what? Pick up the heat that's being transferred through. So is everybody good on that? We've had a victim laying in a tub up against a glass shower door. You couldn't see through the door, but you could see what? A white spot where they were laying in contact with the glass. Does everybody see how that could happen? Okay. Now this one. Same thing. Different, right? Now I am going to touch it and leave a heat signature, right? Which the camera will then be able to pick up. What's the scenario here looking for a victim? If I walk across this floor, what am I creating? Heat, friction. Can you track that? As long as that floor stays cool enough that I don't lose that temperature difference, yes. We've been able to follow crews ahead of us doing a search by looking for what? Their heat signature. It looks like a snail trail going down the hallway until it gets hot enough. If it gets hot enough, you're going to lose it. But for a while, we've got it. Because here's the other scenario. What's that? Exactly. This guy's here, fire alarm, smoke alarm goes off, he jumps up, but boom, he hit the smoke layer, and now he's down somewhere. But what are we going to see? Remaining heat signature, right? Assuming, once again, this doesn't equalize in temperature. So these are all things, when we see stuff, we've got to understand what are we seeing and why. What does it mean? That's image interpretation, all right? So, stand up. Say hi to your neighbor. Do a couple jumping jacks. Drink your caffeine. So, get the blood flowing. This will only absorb what this can endure, right? So, kind of, is everybody good? Okay, we're about the halfway point. So, has anybody learned anything? Honestly. Have you learned stuff that you can take back and use with your departments? Okay, now we're going to get into the new fire dynamic stuff. But does everybody understand why I put this in the program? Because if I go straight to the NIST UL stuff, does that stuff matter? Yes, because if you don't understand that stuff, then you're not going to what? Understand the next stuff that we're getting into. Does that make sense? If your people don't have that foundation in thermal imaging, how effective, efficient are they really going to be? How safe are they really going to be? So does everybody kind of understand where I'm trying to get at with that, right? So now we're going to tear off into the next one. Here's the NIST UL stuff, and it's all available on their website, so you can go check it out. But the good news is a lot of this stuff, basement fires, vertical ventilation, fire spread, that all has thermal imaging material built into it. So once again, hats off to all those folks, Dan Madrikowski at NIST and Stephen Kerber at UL. If you're not aware, UL has already five full-blown training programs that you can check out on their website for free. All you got to do is put your email in, sign up, and for free. Has anybody been through these? Okay. So check them out. They're great. They're free. Once again, all that information's in there. Go there, sign up, knock yourself out. As long as you got access to a computer, it's there, it's free. So is everybody good on that? And once again, I can only scratch the surface of what is there. What I'm going to talk to you about now is 1/100th of what's available to you there, okay? So please, when you get back, go back, dig into this stuff, look at this stuff, use this stuff. And once again, thanks to those guys, because when I email them and say, hey, can you send me this or can you help me with this, I get a response. Who am I? One of a million people emailing them. But I've never contacted those guys and they haven't got back to me. So if you see them, tell them thanks. If you see them, take advantage of the material. Here's what we're going to kind of hit on. So we're going to talk about some of the new fire behavior, exterior smoke, rescue profiling, flow paths, look a little bit at PPE real quick. Does that look good? Is most people in here familiar with this? So nobody's seeing anything up here that's foreign? If we talk about flow paths, people understand flow paths, yes? So they're succeeding, good, okay. So now we're going to get into it. From the exterior, can a thermal imager be used to evaluate fire behavior, structural integrity, or rescue profile? How about all the above, right? Okay, so let's take a look at that. So, running down, we're going to run through these real quick. Also, once again, a thermal imager is another tool layer option, right? We don't stop talking to bystanders. We don't stop reading smoke. We don't stop doing the things we've done. We just what? Add to it. So is everybody good on that? So once again, never let this replace anything. Can we identify our fire behavior from the exterior? Yes, definitely. Closed or open box, free burning, vent limited, contents or structure fire. If we don't have smoke coming from the structure, is that really a good indicator of anything? Be careful. Because I've had a lot of people pull up and say no smoke showing, and what do you hear on the radio a minute later? 1075 or working fire or fill the box, right? So watch that smoke doesn't sucker you in, and they've done a good job at showing some examples of this. We start off with the fire, and it's puffing out smoke, so, you know, we may be a block away, we may see it, we may pull up in the neighborhood and we're encountering it. But within a little bit of time, what happens to the smoke? It stops. Why? Vent limited fire. Yep, pressure change. It no longer can generate enough heat or pressure to push that smoke out, so it stops. This is the ticking time bomb, right? This is when you pull up in the neighborhood and there's smoke everywhere, but you're looking at the building going, smoke's not coming out of anything. Should you recognize that immediately? Hopefully you do, right? Because you know if you open this box up, what does it want? It wants air. And if it's going to get it, it's going to get ugly quick, right? So a lot of people say, yeah, okay, you know, we had smoke, we lost it, we had smoke, we lost it. That's all what? Those lab fires, right? That doesn't happen in the real world that way, okay? Yeah, right, okay? Here you go. Actual fire we had a little while ago. This is what we had showing on arrival, okay? So we pull up, the guys called it from blocks away, working fire, and they get there, they've got a lot of smoke. Also happens to be the girl who's in this third floor apartment. She'd come home, put food on the stove, fell asleep, kitchen fire. Smoke detector wakes her up. She comes out to a fully involved kitchen, burnt badly, smoke inhalation trying to get to the front door. She can't do it, so she ends up bouncing out on the balcony. So this balcony door is about halfway open, and she's out on the balcony. So our guys see her, so they immediately start throwing a ground ladder to make the rescue. Simultaneously, we're stretching a hand line up the interior stairs to get to the fire to put it out, right? Minute and a half goes by. Oops, what happened to our smoke? Is that because we're hitting the fire? No. Sliding glass doors only open about that fire. What's happening? It's vent limited, right? It's a bidirectional flow path, but it can only do so much, right? So it is choked and run out of air. It wants air. We haven't opened the front door yet because we don't have water. We haven't done anything else, so we're holding what we got in the hopes that water's going to get there. We'll grab her. She's 300 pounds plus, burnt very badly. She's not coming off on a ground ladder. So we've got 2 firefighters up here now, and their plan is what? Hold her. We're going to knock the fire out, and then we'll deal with it. Pumper at this point will not go into pump. Hard failure. Absolutely will not go into pump. So we've got a line stretched, but absolutely no way to get water to it. So we're now going to plan B. Well, as luck would have it, there's enough heat on this sliding glass door that what happens? It fails. Simultaneously, the front door starts to burn through. The guys outside the front door who waiting on water, which is not going to get it, said it was literally belching, sucking, belching, sucking, belching, sucking, and they know what's about to happen. It's about to light off. Well, guess what? It lights off. Still got 2 firefighters on the balcony with that victim. Okay? Fortunately, their training had taught them to do what? Get low as you can, and they shoved her in the corner and laid on top of her. They both sustained second-degree burns off of that. Fortunately, too, our crews on the ground had already done what? Pulled lines off of another truck. As soon as they saw fire flash, what did they do? They flowed water. How many people would have said, you can't do that? What am I going to not do? Let them lay there and burn, right? So fortunately, they knocked the fire down. Like I said, our 2 guys ended up in the hospital with some second and third degree burns. Fortunately, she died. She was going to die anyway. She was burnt bad enough from the get-go. But does everybody understand what's going on here? Do we have to recognize this and work with this? Absolutely, because it is real world. So if we don't understand what's going on, consequences, okay? Now, somebody says, well, what the hell does this have to do with thermal imaging? Well, now you show up and you don't have the smoke. But what am I looking for? The heat. So if we had the smoke in the neighborhood or we saw the smoke, but now we get there, no smoke, what am I looking for? Heat. I'm looking for that heat that should be an indicator that I've got what? A smoldering vent-limited fire. Should I be able to see that heat? Is that one of those yes or no answers? There you go. Bingo. We got to look at the construction. So we got to be smart enough to look and say, this is out of their horizontal ventilation, and they've looked at fire conditions behind windows and doors. These are older style windows, and they're immediately showing what? Conducted heat. This is a window here. Can you tell that? No, because it's a very good what? Insulator. That's a new triple pane window. And they ran this test, and you can see it starting to develop here. These windows here have actually failed. This window is just starting to show heat. Does everybody see the issue we can have here? So when we use our thermal imager, we always have to look at our building construction. If I know it's a new house, I know it's got triple, double pane windows, should I expect a good read with a thermal imager? Probably not. I'll look, but just because I don't see heat doesn't mean what? It's not there. Does everybody see where we're getting at? So I always look, but I've got to be asking myself, realistically, what should I see, right? Because then we start the process. So we've pulled up, let's say there was a light smoke condition, but we don't have it now, so now we're looking. Okay, white windows, white door, white foundation. Do we have a fire in there? As far as I'm concerned, I'm going to assume yes, but am I going to absolutely put all my eggs in that basket? Not necessarily. Once again, always err on the side of safety. But if we look, we've got high heat in the doors and the windows and the foundation, so I got to ask myself, why would that be the case? Usually fire, right? Okay. So, but always remember this is relative to the environment. So, what am I saying here? No heat here, but here we could have a basement fire, so we're trying to put this all together. So we ultimately look at this. Could we have a false positive or a false negative? Tell me why I have white windows here. If you went back and watched in the video what's on the ground, it's a light coating of snow. It's 15 degrees outside on this day. Those windows are hot because the heat's on in the house. There's no working fire there. Does everybody see what can happen? All right? But always err on the side of safety, right? Hey, I've got heat, so let's assume we've got it. But could we get tricked? Yes. Be careful, because I've seen people sucked in on this. And not because they erred on the side of safety, but because they saw a white window over here, so they assumed fire was there and went there. Turned out, no, it was somewhere else. What were they seeing? One case, it was sunlight being reflected off of a window. Can everybody see how this can trip you up? So we've got to be careful when we do this. Use it, take the information in, but be very careful about putting all your eggs in that one basket. Are you going to make a call on a hazmat just because you see a placard? What have you been taught? Get paperwork, talk to somebody, right? I want to confirm that by 2 or 3 sources. Does everybody see where I'm getting at? So do the same thing. Take that first piece of information from the imager, but then can you add to it? And then always we're going to evaluate as we go on. Because here we've got another one. So we pull up. In this case, you're going to see obviously it's developing. We know it's back here. We can see smoke now, okay? You're going to see fire break out here, but is this all that's going on? Well, that's all I can read, but if I use the thermal imager, could I potentially read more? So now we're going to switch to the imager. Whoa, that don't look good. Okay, we just fast forwarded. That doesn't look good. That doesn't look good. Are things happening here? So we're going to try to read this now, right? So now let's read this. So, what is this? Say it. Why? How do you know that? Did you hear that? Everybody catch what's going on here? If you look at the shade of the tree in the back of the firefighter and this side of the house. What am I seeing? Sunlight. Everybody see what's going on? That is all from the sun. Okay? But now as time rolls on, that's a false positive, I see this and this. Did we start with this and this? Is that from sunlight? No. That's something that's what? Evolving, changing, and going on. Does that make sense that the fire was here? Where's the fire going? What is that? It's a half-level window. What is that? That's the back stairwell in the house. Guess where the fire's going? Up the back stairs. Can everybody see how I can read that? That's why I'm always going to take my thermal imager and try to use it, because here that is a very valuable piece of information. Did we have that without the thermal imager? No. Does everybody see what's going on? The only way I would have known the fire was going up the back stairs was if somebody inside was in position to tell me that, right? But can I read that from the outside now? So it does work. Does it take some effort to understand what you're seeing? Yes. You can't just look and make a call because, hey, white equals fire. May or may not be the case. So is this making sense? Is everybody tracking on this? Okay. This is one of the NIST and UL studies down in Spartanburg, down in Carolina. So what have I got? I got a bunch of smoke. I can't tell you anything otherwise, but okay, yep, I've got a whole bunch of heat here. Got a lot of convection. This is not a single room and contents fire, right? I've got fire or heat in the wall, so this isn't looking good. Come around here, I've got heat. You know, don't have a lot otherwise. Yep, it's there. Okay, that was a real quick, hasty size up. Did I get some additional information? Yes. Could I have slowed down and maybe gotten a little bit more? The key here is I don't, and somebody said earlier, I don't want what? I don't want a company officer that's lapping the building going. Because meantime, we're what? Hello, we're out here, we got a hose line, we want to do something, right? So take the appropriate amount of time, because what did they not really do a good job at checking? Did they check the roof line really well? Or did they check the basement level, lower level really well? So take the appropriate amount of time, but don't turn your lap into a what? 5-minute dissertation. So use the appropriate amount of time, look for what you can look for, but also remember, hey, you got to get back around. Once again, I can't see anything from here other than smoke. If I'm looking with the thermal imager, I don't like that because heat shouldn't be coming out of a porch. Now I actually look in the door. I definitely don't like that. There's more convection coming from the porch. Uh-oh, that's not good. Where's this fire actually at? It's actually below grade. Does everybody see what's going on? Can you tell that otherwise? No. I mean, I can't tell you without the thermal imager. Now, there's low smoke, so read that indicator. But with the cameras, is there any doubt that there's a romping fire below grade here? Does everybody see what I'm getting? So once again, use it because it can provide you very good information. But put it all together. What is the smoke telling me? What is the building construction telling me? Okay? Because if we do that, we build a much better decision-making process, right? Everybody good? Okay. Can we conduct rescue profiling from the exterior? So, if you saw this, this is where they're taking windows for vent, enter, isolate, search. So we take this window and we get no smoke. We've got a romping fire on the first floor. What does it tell me? I've got some separation, right? So I don't have a flow path, right? So we have not created a flow path there. Good. But now we're going to crash the next window over for vent, enter, search. And we're going to get, anybody seen this? We're going to take this window out and now we get this. What do we have? Flow path. I have a connection from the fire to that area, right? So is everybody good on that? So this is not using the thermal imager. What would I expected to see if I was using the thermal imager here? That window was probably dark, and that window was probably white hot. Does everybody see what's going on there? Because that room was not being impacted by the fire conditions, but that one was. Does everybody see what's going on? So could I have also determined that from the ground with the camera without ever having to take a window? Good possibility. Now, if they're insulated windows, maybe not, right? But if they are, would they show it? So, can we use it to help? All the time, some of the time, none of the time. It's going to depend on building construction. If the building will show you things, you can use it. If it's a new building, energy efficient, masking, you may not be able to use it. So look at your building construction, but try. You don't know till you try sometimes, right? So now we're going to take a look at this. So now I'm looking with the thermal imager. If I'm going to make it a priority to go in windows, which ones are it going to be? Is that being impacted by fire conditions? Is that one? Is that one? Not as bad. Does everybody see what's going on here? So if I'm going to go to the greatest area of risk first, where's it going to be? There or there? Does everybody see what's going on? So I now have that to help my decision-making process, right? Also, when I open these windows, I should probably expect something's going to be coming my way. So if I take that window and boom, here comes the smoke, that's confirming I've got a flow path from me to the fire. Is everybody good? At that point, it's very important that we do what? Isolate. That's why we stuck that I in there, right? Because used to be it was vent enter search, so we would bail in there, but we would forget a lot of times to close that door, so that flow path's rolling, so don't forget. Now we look at this one. This is from Kill the Flashover. So same thing, we've thrown up our ladder, we're going to go up. Can I see some heat? Yeah, there's some there. So I'm asking myself, maybe I'm getting some of the picture. Okay, there's the smoke. Now I'm getting, yeah, there's no question I've got what? A connection to the fire there. So I know between the imager and between what I'm seeing, this room is connected to the fire. This is going to become a flow path, right? So it is imminent that if I go in here, I what? Get to the door. So I'm going to bail in here, and we're going to go in, and you'll see him here clean the window out, and he's going to go in. So that's a good heat condition, but not red, so we're going to probably go. So that's something we could look at. You know, what are you feeling? What are you seeing? There's yellow. It's warm in there. So he bails in. The second firefighter comes up with a thermal imager. What is he doing? Monitoring conditions, tracking that other firefighter, right? Is that the best way to do that? So I'm going to throw this out. We're pushing vent, enter, isolate, search. What are we not pushing? Well, I mean, in this situation. Where did the camera end up? With the guy outside on the ladder. Where should the camera maybe have been? Does everybody see what's going on? Because now let me throw this one out. Here you go. You heard it here first. I don't know if you did or not, but I'm going to throw it out here, right? Vent, scan with the thermal imager. Would that make sense? Because if I've got that imager and I'm up there, as soon as I vent that window and I look, could that help? Do you want to go in this room? Because we say enter, but should we enter if warranted? Because here's my question. What is below this floor? A romping fire condition. You can see it. Now, traditional vent enter search, I'm going to poke in with my tool. Is that going to really tell me if that floor is stable? Or is it just going to tell me what? Something's there. Does everybody see where I'm getting at? So now I've got to ask, if that's a romping fire condition and this is lightweight construction, how confident are you bailing in that window and hitting that floor? Does everybody see where I'm getting at? Especially now that I've searched this room from the window and do I see a victim? Now, could there be one underneath the bed? Sure, there could be a kid underneath the bed. So if I think conditions warrant it, are we going? Yes, because I've got to get under there and get underneath that bed. I can't do that from the window. But, once again, size it up. Look what you've got. Do I need to isolate? Do I need to isolate? The door's already shut. Does everybody see what's going on? Does it make sense for me to bail from the window and run to a door that's already shut? No, right? It's already there, okay? Now, I may want to pop it and check real quick on the other side, but I can already tell you from the window the door's shut. Could this room still be full of heat and smoke? Yeah, because that door could be what? Starting to fail. Does everybody see what's going on? It is. You can see it's starting to come around it, okay? So, what about search? Well, boom, there's my victim. Where am I going? Straight to my victim. Could this expedite and simplify the process drastically? Is this the only answer? No. Are we still going to have to go in areas and check them? Are we still going to have to make decisions? But would it make a hell of a lot of sense that as soon as you take that window, you do a quick scan of that room? Does everybody see where I'm getting at? Yet are we teaching that? I'm asking. I mean, are we? Okay, you are. Good. If you are, then more power to you. Rock on. You know, now, if we don't have the camera, does that mean we're not going to do vent enter search? Yeah, we're still going to do it, right? But could this change that process? Food for thought. Is everybody good on that? So think about that and go back and say, hey, is this something we want to add? Okay? Yes?
True or not true, isn't VEIS basically specific for a firm victim in a known location?
Is VEIS for a known victim in a known location? Usually, yes. But
I guess it goes back to what you said, that if you're scanning the room and you said, well, maybe I should or should not go look under the bed. Yes, you should, because you're saying that's where you've been told there should be a victim in that room.
yes, but here's the key. Do we still do VEIS when we don't know we have a victim? I pull up, I've got 50%, 3/4 involvement. Can we make an interior search? No, right? Until we what? Initiate fire attack. So I know the area that's not involved is a bedroom because it's a ranch or whatever. We still may what? Do vent enter isolate search. Not because someone told us, but because that's our quickest, most effective way to try to do a search given conditions. So is everybody tracking on that? So I mean, this is plan A, plan B, plan C, right? And once again, I want to make sure everybody's clear. Is there 100% guaranteed just because you look with a camera that it is clear? No. So when in doubt, what? Physically go in there and search. Is everybody good? But do I want to bail in a situation to search that I don't need to bail in or I shouldn't be in? No. You know, is the day going to come when someone's doing vent enter search and they end up in the basement? Yeah, it's probably already happened. I know at least one case where they've partially gone through the floor doing that. Because once again, what do we see with the video shot out in California on the roof operation where the firefighter fell in the garage? Was he sounding the roof with a tool? Did it ever give away? It did when what? 300 pounds hit it. Can you sound the inside of a window with a tool and have a solid surface until what? 300 pounds hits it going into windows. Everybody see where I'm getting at? So things to think about, right? Question? Yes. We'll get to it. We'll get to it, all right? Yep, good question. All right. Can we evaluate collapse from the exterior? Now we're talking interior, but we'll do both. We've always got to look at the building construction, right? And ask ourselves, will it show us and what do we have? So if I'm looking here, and this once again was their residential attic fire study, and there's video after video after video. So make sure you get in here and look because there's some really great stuff. Now the point I want to make here, and we'll look at it a little bit more, is this is the normal view, this is the thermal image of this. This is the interior view, and this is the thermal image of this. When they do these studies, where would you expect to see heat with a thermal imager? I'll see it on the roof line. You can already see it. Can everybody see it? Where am I not going to see the heat? From the interior. Because what on the interior is between me and the fire? Drywall, sheetrock, insulation, flooring. Does everybody see where I'm getting at? What's between the fire and the roof line? A piece of OSB and some shingles. Does everybody see the difference? You can usually identify attic fires from the exterior, but most of the time you have a lot of trouble identifying from the interior. So does everybody see the difference? But that's why I started this process from where? The outside. Does everybody see? Because I get guys on an attic fire that want to run right in and start looking. What are they seeing? Nothing. Because that box is built to be insulated where? At the ceiling. You don't have the insulation where? Outside on the roof. Is everybody good? So make sure you think about that when we're looking at attic fires. Because when we look at this, this is how we start. Very light smoke, but notice what? What kind of construction is this? This has a ridge vent. Does everybody know what I'm talking about? So the whole ridge is vented. That's why you can see all this heat immediately at the top. You can see a little bit on the gable, but a lot there. As it progresses, a little more smoke. Where's the main body of fire at? It's right there. Can everybody see how quickly we can identify that from the outside? Was that a help? Because now do we know where on the inside right to go to get to it? But that was all done from where? The outside. Because if you're standing inside looking up with the camera, what are you not seeing? You're not seeing that heat from the inside. So does everybody see where I'm getting at? So make sure we run through that. Now we go to this, and then we go to this. Now I'm going to throw this up there. Why does that image look drastically different? Why can I see all the construction detail and the heat, and why can I not here? Bingo. Back to modes. What do you notice? High sensitivity. What do you notice? Medium sensitivity. Does everybody see what happened? So if I want to go back to this sensitivity level, what do? Take the camera off those heat sources. And does that make sense? And then it'll shift, and then you can kind of work your way back. So does everybody understand, once again, how this works and why we need to understand this? I don't want to be evaluating conditions in low sensitivity because I can't what? I can't see detail. I always want to evaluate in high sensitivity. Question, comment? Depends on the thermal imager. Some thermal imagers trigger off the center, some trigger off the overall image. So once again, you've got to know your thermal imager. Some of them, and that's a good question, thanks for bringing it up, so is everybody good? So you need to understand how your thermal imager triggers. It could be a percentage of the overall image, or it may be the crosshairs in the center. So is everybody good on that?
So when you're in a higher heat environment, it goes into
low sensitivity. Yep.
gives you the least quality,
Right, the lowest, right, exactly.
which is probably the environment you're being in that PEIS.
Right. So where do I want to keep the camera pointed?
But if you take it in that room with you, you're probably not going to have very good quality to
You may not. Yeah, you may do better from the window because you can take some of that heat out. I tell guys, always try to keep the camera where? Low if you're in heat, because that's where you're going to see your best things. I can point a camera at this wall at the ceiling and not see that door because of sensitivity issues. But if I point it at the floor, does that door all of a sudden pop out? Yes. Does everybody see the difference? So if you're looking for victims, egress, the details, what do you want? High sensitivity. How do we get that? Stay out of the heat. Is everybody good on that? Okay. Taking a look at this. Is this fair to say this is from fire? Even if you didn't have the convection. Dark window, dark window, dark window. Why are these light and these are dark? It doesn't make sense. Does everybody see where I'm getting at? There's a reason these are light and these are dark. In this case, it's because, yes, we've got a fire up here. But now let me ask the question. What if I tell you that that is lightweight truss construction? What are your thoughts on putting people on that roof? What are your thoughts about having people under that roof? Does everybody see where I'm getting at? What would you see from the outside in this case? Light smoke condition coming from the roof. Can everybody see the difference there? So once again, try to use it, try to see what you're getting into. But does building construction matter? You bet. Because if you don't understand it, you're going to have a hard time interpreting these. Okay? But if I wouldn't say this is an energy efficient window issue, because it wouldn't make sense these are showing heat and these aren't, if they're what? All the same kind of window construction. Is everybody good? So that's, yes.
One question I saw from videos watching on the internet too is when you have these gas flashes, lightweight truss construction, it is literally like burning away. It is not falling in. It is burning off as fast as it is. So my opinion would be that if you get in there full ceiling as fast as possible, you're going to have a much better success at knocking it down than the less rigid slabs.
Strategy versus tactics discussion. And no, I'm not arguing with you, but does everybody see where I'm getting at? I'm just saying it's a call. Because I can have total collapse, general collapse, or I can have localized collapse. And that's an issue to get at where I'm there. And yes, I mean, that's a strategy and tactics decision somebody's what? Got to make. But would you rather make that decision just seeing smoke, or would you rather make that decision seeing that? Does everybody see where I'm getting at? So are we good? Yeah, I mean, I'm not going to argue with you on that one, so, okay. This is also looking at the attic fire, but what they also did here was wall experiments, because the question was, if a fire starts on the exterior, what is it going to do? We all know usually it runs up the wall and gets in the eaves, right? But their question was, what about it also getting in the wall? So what they do is they build these wall sections, different types of construction, and start a fire to see how rapidly it can get inside the wall. So what you're looking at here is, you know, this is the outside quote, this is the inside. Does everybody see what's going on? So from the outside, it looks like it's staying on the outside, but now we're checking on the inside, what are we seeing? Well, as this progresses, what am I starting to see? Heat transfer. So now I've got a question, hey, there's a good chance I might have a fire in this wall now, right? But here's one of the issues with the way they did the experiment, and I've talked to them about it, and they said, yep, we screwed up, we'll fix it. This is what I'm seeing initially. What mode am I in? High sensitivity mode. But then what happens is I shift to medium sensitivity. What just happened to all this heat signature? It's gone. Is that because the wall got any cooler? No. Is that, if you came in that mode, would you see that fire in that wall? No, but you should be in what? High sensitivity mode. Why did it go to medium sensitivity? Because this fire's coming in the picture. Would that happen in the real world? No, because you'd be inside the buildings. Everybody see what happened. They kind of boo-booed on their test here. They should have kept the camera just focused on the wall, because then what? This mode change wouldn't have happened. But I've already had somebody come to me and show me one of these images and say, yeah, how's your camera working? I got a ripping fire on the other side and I'm not seeing crap in the wall. They don't understand what's going on. Does everybody see how that could be an issue? So could this be used to tell you something's not going to work when in reality it would work? Does everybody see what's going on? So we got to be smart enough that when people hand us stuff, that we really take it for what it is. Does everybody see where I'm getting at? Because I could easily stand up in front of a class and say, thermal imaging cameras suck, you can't see a fire in the wall, but not explain what's going on. Does everybody see what's happening here? So, you know, something to think about. Get in there and look at that information, because they do 20 different types of wall construction, and it's amazing how quickly fire does or doesn't spread and how easily you can or can't see it with the thermal imager. Is everybody good? So that's a good resource to look at, all right, because that helps with the building construction question. Now we're going to go on our fire attack. So here's our favorite transitional attack, no strategy and tactics discussion. But my million-dollar question is this doing anything? So I'm going to dump water in here. What do I want to see? Change, right? I want to see this stuff go away. Well, I've already dumped the red, so now I'm down in the yellow, and now I've dumped all the yellow pretty much. There's a couple window panes that are still hot. Did we just take 90% of the energy out of that box? Yes, right? So I can see that with the camera. I can verify that with the camera, right? So now we got to what, though? Follow up, right? Because it's not out. So, but now what am I walking into? Do we see a lot of heavy convection? No. Is there a lot of heat left in here? No. Am I worried about walking into a flash over here? Once again, know your camera. Now, you're going to see here we went into low sensitivity because they pointed it at the wall. But what happens when we go back to the heat? It's going to shift modes on us. Oh, we just went into low sensitivity mode. So what is still in this room? There's still heat and energy in that room. So in there, we need to be checking. But does everybody kind of see what's gone on and how we've seen? Because normal visibility in this building at this point is what? 0. You can't see your hand in front of your face. But if we've got the camera, we can evaluate that quickly. All right? So here's another one talking about hose streams. Straight stream in the window. This is looking up the stairs. What is it doing to the thermal balance? Nothing. Okay? We're not seeing it getting blown, pushed, changed, but we are seeing it cooling the environment some, right? But now we're going to do our old friend, Mr. Fog Pattern, right? So now we're going to come up and we're going to dump a fog pattern in this window. Now watch what happens to your thermal balance. How would you like to bend the people on the way up the stairs? What does it actually do over here? Can everybody see what's happened? Can you push fire? You just saw it. What pushed it? Air. What didn't push it? Water. Does everybody understand the difference? We could argue about this till we're freaking blue in the face talking about it, because before we could never what? See it or prove it. But now I can see it and prove it. It's there, okay? Now, I will tell you, I was up on the second floor, very involved, in the attic. We're trying to get to it. Somebody outside, good-willed and intention, decides what? We're going to do an exterior attack. The problem is we're inside. There's issue number one. But they also decide to do it with a broken string. I'm in a room, and all of a sudden I can see kind of light convection, and then what do I see? A white cloud coming at me at a high rate of speed. What is it? All that convected heat and steam. I was fortunately able to do what? Kick the door shut, and that gave us some viable space. The people out in the hallway weren't so fortunate, okay? So we got to be able to look at that, read that, and understand what's going on. Are we good on the exterior? Did anybody learn anything there you did not know? Is the wheel spinning? Are we learning? Can we use it? All right, home stretch. So now we're going to go inside. So now we're going to try to evaluate the conditions. And I'm going to go a little bit faster to try to get this in. But what is causing this? Smoke is going in, not going out. Should it be doing that? No, right? Bad, right? So the million-dollar question, we'll come back to this one. What is causing it? What would you think is causing it based on the fire dynamics? Vent limited. It's wanting to pull air, right? I'll show you what's causing it, all right? Now, is there any convection in here? Can't see it. That would be because perspective, right? Is there any convection in there? Why did we not see it in the room? Because everything in that room is the same temperature. It's preheated. This is a good example of a fire that's sat and preheated everything. Inside, the camera can't see it. But when I'm outside, what do I have? Those differences in temperature where it can register. Does everybody see what's going on? That's why I stress starting this process from where? Outside. Guys will get in a room and never check at the threshold and look up and go, hey, we're good, no convection in here. Be careful. Can everybody see what can happen there? Okay. Light convection, right? Am I worried? No, we're good. It's firefighting, right? But what's that convection also telling me? Direction the fire's in, right? So that's a usable tool. Are they all going to look like that? That's a BST camera. There's your microbolometer. Does it look anything like that? Okay, and here's another one. Does it look anything like that? You've got to understand what your thermal imager is actually going to show you and how you read it. Is everybody good on that? And going back to the BST, yes, it looks beautiful. That's pretty good. This is a newer camera. It's doing better. What's that? A blob. I can't tell you direction, definition, or nothing. Is everybody good on that? So make sure you understand how your imager is going to show you things from the inside, because they are all can be vast, definitely. Could you have that in your department right now? Yes. So do your people need to understand what they're actually reading and seeing? Because they're going to see three very different things. Does that make sense? Okay. So we look up at the top of the stairs. Yep, there's some convection and some heat, so let's go see what we got. So we roll up. It's a microbolometer, so it's not as obvious, but it's there if you look. Can everybody see it? So it's coming out. So, okay, what do we got at the top of the stairs? We're going to check left, check right. Yeah, it's definitely going that way, all right? So we peek in here. Okay, there's the fire. Now, I'm on a search crew. I don't have a hose line. What am I going to do? Close the door. Once again, what would that do? Well, I'll show you what it'll do. This, once again, is from Kill the Flashover. Ceiling temperature is 1,000 degrees. We're at 750 at 4 feet. Is that a good place to be? Do we have survivable victims in there? Probably not. So I'm not so much worried about shutting the door, because if they're in there, chances are they're probably dead anyway. But what am I worried about? That fire changing, growing, or spreading, right? So we close the door. What just happened to our temperature? It's dropping, right, significantly. Where'd the red go? It's gone. We haven't changed modes. We're still in the same mode, right? But what happened? We dumped 50% of the temperature in 17 seconds just by closing the door. Can everybody see what happens here? So once again, FDNY is huge, and a lot of other people are on door control now, right? So we've got to be thinking about flow paths, using our cameras to see what's going on. and start compartmentalizing the building. Does that make sense? Because then we can stop this or slow this down. If we don't, we're sitting in the barrel of a what? A gun, loaded gun. Is everybody good on that? So we can read that and see that. Now, once again, a lot of convected energy sitting above our heads. It's at the 50% mark. Do I want to be sitting in there? BST now, yep. Okay. Do I want to be sitting in here? No. Look at all this radiated heat onto the floor. If this is full of furnishings, what's about to happen? They're off-gassing at this point, and we're on our way to a flashover, right? So we've got a hose line. Let's flow some water and see what it's going to do. The key here is to use a straight stream so we don't take all this and do what? Bring it down on ourselves. So we flowed a little bit of water. What did we do to the conditions? But did we? We didn't change those conditions. We did not what? Flow near enough water in this situation. Does everybody see what's happening here? Watch, because you're going to see it right here. This comes rolling out. We open the door. It's initially high and it's moving. Watch, and all of a sudden you'll see what? Boom. Does everybody see it drop? And does everybody see it boil? What's coming? Boom. How much warning did I have? Seconds. Don't sit there with the camera going 5, 4. Does everybody see where I'm getting at? No, not a good idea. If you see that, 2 options. Flow water and cause a change in the actual conditions, or you need to be getting out of Dodge. Is everybody good on that? Okay? Or close back the door, exactly, because the easy solution to that problem, close the door, right? So we'll look at some more here. Flow path. This is a really good study on the wind-driven, and this is not even one of the wind-driven ones. This is just natural ventilation, but here's the fire in this room, and it's going to progress. This is out in the common hallways. Everybody seen this one? There's nothing in this hallway but basically non-combustible materials. Can you die out here? Why? Exactly. You're going to be in the flow path. Is your warning indicator here at this point? Should you recognize it? Because if you don't, when this window fails, how much time are you going to have? Seconds. Watch. Window starts to fail. It's pushing. It's breathing. It's telling you. So they're going to help it. Watch how quickly. What just happened to the temperature in the hallway? You're in a friggin' blowtorch. Is everybody good on that? So we good? All right. Okay. We'll skip this one because we'll come back to it. PPE. That's face piece failure, but this is a flow path. Where's it going? It's going up the stairs. Can everybody see that? What's my problem here? Does anybody catch it? Look at his gear compared to everybody else. He came out of there with second-degree burns. Can everybody see what's going on? Nobody can understand why all of a sudden he jumps up and what? Bolts for the door as hard as he can. Everybody else is like, what the hell is he doing? He's burning. I can clearly see that on the camera. Should somebody register that? Yes. And the thing is, because once he registers, it's what? It's too late. He's burning. Is everybody good on that? Okay. Yeah, and that was a training drill, and we end up with a guy with second-degree burns. Yep. So look here, because you initially see the heat and the white, but what's going to happen? Mode change. What just happened? He magically got cooler, but did he? Does everybody see what's going on? So we got to understand what's going on with that. I'm going to finish up here, guys. I apologize for running late, but like I said, I'm trying to shove 4 hours worth of stuff in an hour and 45 minutes. But talking about hose stream impacts here. This is what we're teaching some people. Be very careful, because should we hit that? Without a doubt. Okay, well, we're going to hit it. What are we going to do? Penciling, right? So we're penciling it. So we're hitting it. Are we really changing the condition? Does everybody understand what I'm getting at here, right? So you'll see here they're training them to pencil it. So you'll see them smack it a couple times and stop. I can tell you the pump operator's not happy because some of these guys are doing this and the hose is doing this. But also, like this guy, is he really changing the conditions? Very minimal. I mean, 2 seconds of water and 2 seconds later, what? we're right back where we're at. Yeah, this is not a pencil it, this is a hit it and hit it good to change the conditions. Is everybody good on that? So once again, use your camera to read and look at that, all right? And I'm going to roll through this to hit one of the last ones here. Question was on the floors. Taking a look at that. Once again, look at their material and you'll see this. Don't want to be on those stairs, right? Everybody good? So, looking at this. This is the NIST study, so go on there. It's all there. Temperature measurement. Is it registering the difference? Temperature measurement is showing me 80 degrees when I've got 1,300 degrees. Is that floor a good insulator? Yes. So floors can be very good insulators, right? Watch because they can mask conditions. Don't get hung up on the floor conditions as much as looking at the big picture. The floor is not telling me the answer here. What's going to tell me the answer? Exactly, the other areas. So now let's take a look. The floor is really not the answer because it doesn't change that drastically. It is a good insulator. But what is showing me? See the heat in the ducts, see the heat in the walls, see the heat on the registers. Does everybody see what's going on? So be careful because if you do that, you should be able to pick that up. So is everybody good on that? So lights are on, that means it's time to go home. So apologize, like I said, it's a lot of material. But honestly, did anybody get anything out of it you can take back and use? Get in touch with me, and I will get you the information. So the stuff we had to skip, you can see and you can work on. All right? So I appreciate everybody sticking around. Everybody have a good conference. So thanks.
On behalf of FDIC and Penwell Corporation, I want to thank today's speaker, Mike Richardson from St. Matthews, Kentucky Fire Department, for today's presentation, Using Thermal Imaging and Modern Fire Dynamics to Improve Fireground Operations. This presentation will be archived within 24 hours and can be reached from the homepage of FDIC.com. A reminder email message for the archive will also be sent to all registrants, complete with a direct link to the archive. We thank you for joining us today, and we look forward to bringing you more webcasts in the near future. Stay safe.